That was a reminder. For more Microsoft webcasts, you can visit microsoft.com/webcast. And again, I'd like to welcome everyone to today's MSDN webcast, Offline Data Synchronization with Microsoft Sync Framework. Now, without any further delay, I'm going to turn the floor over to today's presenter, Lindsay Ritter.
All right, thank you, Tracy. Well, welcome everybody to today's webcast, where we're going to give an overview of the Microsoft Sync Framework. We'll take a look at the scenarios that the Sync Framework helps us to provide in our applications, and then we'll step through some of the components of the Sync Framework, such as sync providers that are available for you and how to create your own sync provider. And then lastly, we'll take a look at a demo of the Sync Framework in action. Just so you know, again, my name is Lindsay Ritter. I'm a developer evangelist with Microsoft in the Mid-Atlantic region of the United States. And on the screen right now is my blog address, blogs.msdn.com/Lindsay. So should you have any questions about today's webcast, please feel free to head out to my blog and send me an email, and I'd be happy to help you out. So what we're going to cover today is an overview of the Sync Framework. We'll take a look at some of the scenarios that it helps us alleviate, the vision of the Sync Framework, and then finally, of course, the implementation and the approach. I will take a look at synchronizing what we call endpoints, and endpoints are basically the places, the reach as to where you're going to be changing data. Data is going to live. The example we're going to see in our demos is using contacts as our endpoint. So, you know, email contacts, business card contacts. The endpoints that we're going to use in the demonstration scenario are going to be Microsoft Outlook as a place where you store your contacts. Windows Vista has a contact section. Maybe your mobile phone. So all of these three different scenarios, the mobile phone, Outlook, Windows Vista, are three different endpoints. And so to expose those endpoints to Microsoft Sync Framework, we use sync providers. And we'll take a look at that architecture momentarily. Lastly, we'll take a look at adding sync support to new endpoints that don't have a sync provider, so you will have to create one. So the vision behind this synchronization framework, actually not synchronization, Sync Framework, Microsoft Sync Framework, is that we want to allow developers to build applications giving your users the ability to access their data on any PC, so any computer, on any device like a mobile phone, for any service, regardless of the content type. So across disparate applications, they don't have to speak the same language, they don't have to work over the same protocol. It's all about universal and ubiquitous access. So the Microsoft Sync Framework allows us to enable applications for offline scenarios. So if you're on a plane and Outlook, you need to work with Outlook in cached mode. It's the same kind of situation if you're disconnected and you want to still work and have access to some kind of data. We'll give that to you in your application. Also with roaming and sharing your data across disparate endpoints. Maybe you're on a mobile phone and you're walking to Starbucks, and Starbucks has Wi-Fi, and so you're connected, and then you're roaming somewhere else and you're disconnected and you go to a connected scenario. Or you have a laptop and you come into your office and you sync with your PC and you sync with your mobile phone, and then you take your mobile phone, make some changes, bring it back, and make those replicate those changes to your PC and your laptop. So they all need to be on the same page. And then unencumbered collaboration, peer-to-peer networks. What if you want to share data from one mobile user to another without having that server-side interaction? All of these scenarios are solved by synchronization, and therefore the Microsoft Sync Framework. So a couple of key scenarios for synchronization are offline and collaboration, and I just kind of briefly mentioned both of those, but let me go into them a little bit more. There's actually a third scenario, and I'll talk about that in a second. But first of all, offline, and that's kind of the scenario where we're synchronizing data between a client and a server. I just totally lost that. One such scenario, as I mentioned already, Outlook cached mode, where you're disconnected but you still have access to all your information. Mobile information workers, I've also talked about this, having a mobile phone, and maybe you're visiting a client and you're entering some client data into your mobile phone, and then once you get back to your office, you'll resync that up to the server. It's also creating a rich experience for your users for applications that consume web services. On the other hand, we have collaboration. And collaboration is not just about server-client interaction that is disconnected. It's about content flow. We're not necessarily interested in taking data from one endpoint offline. We're trying to make the content, the data, available anywhere. So regardless if we're collaborating, one person's using a PC, one person's using a mobile phone, one person's using a desktop application across the world. We all want to collaborate on top of the same kind of data. So each of those endpoints needs to have a provider that will enable us to collaborate effectively, and we need to be able to synchronate. That's not a word, is it? To sync up those changes. So with the Microsoft Sync framework, what that allows us to do is to add synchronization capabilities to endpoints. And one of the key tenets of the Sync framework is that when we talk about endpoints, we're not talking about you have to create a whole new endpoint if you want to enable it for synchronization with the Sync framework. You can add synchronization capabilities to any type of existing endpoint because we want you to be able to leverage an existing system or an existing data store. Maybe you have a system or a data store that has some version of change tracking or some version of conflict resolution or something. We want to leverage the work that you have already. Or maybe you have a data store that isn't set up to handle synchronization, but you can't go back and modify that data store. Or you're working with a service or a device that you can't go back and actually modify to create a whole new endpoint off of. So the Microsoft Sync framework allows you to leverage that existing technology, the existing work that you've put into it, and therefore still use the Sync framework. And of course, therefore, we wanted to build the end-to-end from the full solution for collaboration and caching and synchronization. Three ways that we think about the Microsoft Sync framework, kind of three pillars about it, is that it's powerful, it's flexible, and it's productive. So we're going to take a look at each one of those pillars and talk a little bit more about that. So powerful. Microsoft Sync framework is the first type of generic Sync framework. There are Sync solutions out there, but when we talk about Sync framework, we really mean in a very ubiquitous, generic, all-encompassing scenario that helps us take care of multiple problems, whether those problems be conflict detection. You have two pieces of data that have both been modified. Which one should you choose? So how do you solve that conflict? And then once you do solve that conflict, it's resolved, how do you propagate that resolution throughout your entire system, through all the different endpoints? And that's a problem in itself because we have different network topologies, latency. One thing might not be connected. Your device might not be connected, so synchronization is very complex. The second point that we have is if we're dealing with, one thing I forgot to mention, numerous corner cases, is that what happens when a delete of some data comes in or a device is restored if it comes back online? How do we propagate the right content? How do we handle the very complex scenario? Because synchronization really isn't just about being able to connect our disconnected application to a connected state. That just connection scenario isn't what the synchronization solves. Synchronization really is, how do I make sure all my data is up to date and all the possible scenarios, all the logic is behind that to make sure that all my data is the same data. So it's not about getting reconnected. It's about once I'm reconnected, how do I make all my data become the same data intelligently? So the Sync framework takes a lot of that work out and a lot of that logic, still giving you much control over it. So the Sync framework is also capable of operating in unforgiving environments. And what we mean by that is that if your network topology changes, we can do simple hub spoke, where you have a central maybe server, and each machine, each device, each service is directly connected to that server. So propagating a change made at an endpoint is easily replicated back to the server, kind of the shortest path. But we can also support peer-to-peer or in a full mesh connected scenario where everybody's connected to each other, or some type of ring topology or any kind of looping topology that we have there. And we also can deal with unreliable networks. So if your computer, your PC gets detached from loses communication with the server side or mobile network, we have an easy way to replicate changes there. So the Microsoft Framework is extremely easy to use in different scenarios, and we'll go over that momentarily. But of course, we try and make it very performant and efficient as possible for an endpoint that might be newly coming into the Sync Framework ecosystem, which we want to, maybe we want to have an endpoint I've mentioned before that has an existing change tracking system, or if there's some kind of existing synchronization capabilities from an endpoint, it's easy to plug that endpoint into this Sync Framework ecosystem. But it's also easy to set up a new endpoint that has no sync capabilities whatsoever. The Sync Framework is also flexible. That's one of the second key pillars. I mentioned at the beginning, one of the key tenets is that we want the Sync Framework to support new and existing endpoints. So therefore, if endpoints currently exist, we can't dictate exactly you must use this type of data store, or you must for synchronization, or you must dictate how the schema is set up, or we must dictate how what protocol we need to use to exchange data. Because we want to leverage existing endpoints, we can't have those kind of dictations. We have to be able to support arbitrary data stores and data types. The Sync Framework approach is that we can operate over any network, over any type of protocol, web services or FTP, what have you, not dependent on the protocol. And you can plug in any type of transfer mechanism and still have synchronization work there. And then topology, when I first started investigating the Sync Framework, I didn't really think of why does a topology matter in terms of synchronization. Data can be exchanged so quickly, but it can, milliseconds, nanoseconds do count. If multiple people are making changes to the same piece of data, and just having those packets get back to the server or get back to the other endpoint, how do we handle, those can create conflicts just how the data is being exchanged over a network. So we can handle any type of topology, any arbitrary topology, from a one-way hub and spoke that I've mentioned, or even a full mesh, peer-to-peer mesh. The third pillar is that the Sync Framework is productive. First off, there's some support built into Visual Studio 2008 via Visual Studio designers and wizards for us to be able to implement local data caching within with our applications. And I'll go through a demo of this towards the end. But basically, we'll use SQL Server, SQL Server Compact Edition, SQL CE, to have a low-code data store, which basically allows us to be more productive when we're working in Visual Studio, because it's a matter of working with wizards and points and clicks, and it even generates some code for us. So it really allows us to rapidly develop applications. We also are internally, we have a couple of sync providers available for you, and I'll go over those momentarily. But internally at Microsoft, we're building synchronization providers, and as soon as we come up with them, we will make them available to the public. We also trust that developers like you will be creating their own sync providers, and via community will share those sync providers. And of course, we'll be working with partners, Microsoft development partners, to create synchronization providers also. One such example of a synchronization provider, sync provider, that we're going to take a look at is file folder sync. So we can sync between maybe a USB key or any type of NTFS or FAT drive, like a removable drive, replicate your folder structure between something on a removable drive and your PC. So if we have these sync providers that we provide for you, it's just a matter of you as the developer of configuring this provider to work particularly in your scenario. So you really don't have to put that much logic behind how it's going to sync. You just need to give it the criteria and the policy to sync, maybe of how it's going to handle conflicts or something like that. Did I want to say anything else about that slide? Oh, yeah. The last point is that it's a comprehensive runtime, makes adding support for new endpoints really straightforward. You really wanted to make sure that the sync runtime was really straightforward in order for you to create new endpoints or new providers for an endpoint. So we just have our core model is a plugin model. We just want you to be able to expose the endpoint through this provider, a sync provider that you can create, which is basically an interface, and then the sync agent, we'll talk about this topology momentarily, I'll go through a diagram. The sync agent really takes care of the rest. The sync agent talks to the sync provider, which talks to your endpoint, the data store. It's a logical runtime. The sync framework is a logical runtime. It's hosted within your application. It's not like a long-running service and then a long-running NT service or anything like that. It's just a logical runtime hosted within your application, and the sync framework gets kicked off from that runtime. I shouldn't say the sync framework. The synchronization part is kicked off from that runtime, from the sync agent. So these are the components that make up the sync framework. We have 4 different layers. I'll start from the bottom up because we're going to kind of get more granular from the beginning. The base layer, we have the sync runtime. And sync runtimes are basically APIs for dealing with the metadata. Metadata is, I'll go over this momentarily, but the metadata is really what empowers the sync framework. It's how your sync providers are going to communicate and make sure they handle changing is by taking a look at this common metadata. And that's what makes it a protocol or data store agnostic, is that we don't care what type of data store, what type of protocol we're working over, we just care about this metadata. So in the sync runtime at the bottommost layer are the APIs for dealing with this metadata for a multi-mastery sync system. And when we think of multi-mastery, we're thinking that there are multiple endpoints, multiple applications, multiple devices, multiple services that can have an impact on the data. So it's the core of the framework itself. On the next level up, we have sync provider services. Basically, they're services that allow you as a developer to make it really easy to build your own sync providers. For example, if you're using an existing data store, we have something like these anchor providers. These anchor provider services, basically, you have some of the work put in place, but we will leverage the capabilities that you have within your data store and add the more functionality above that to make that endpoint have an appropriate provider. Then we also have simple providers for if you don't have any type of architecture put in place. And what if you're not available, or what if you're not able to store any metadata information, which is kind of the common language, the common metadata that we need to exchange between providers to allow synchronization? If there's no place for you to store that with your data store or with your item at all, we give the ability for you to store that metadata somewhere else, because all that we require in working with the sync framework is that you're able to exchange that metadata. So if you don't have any place to store it, we help you find a place with the metadata store. The layer above that are the built-in sync providers. And these are the providers that come out of the box. Right now we're in TTP2 with the sync framework. So these are ones that come out of the box. The FeedSync 1.0, I'll talk about that momentarily. File system providers, relational providers for relational databases. And then as we come in the future, Microsoft will introduce other providers as well as third parties, like from the community or from Microsoft partners who will introduce more sync providers. So basically, Microsoft will keep investing to create more sync providers for you to use out of the box. FeedSync 1.0 used to be called Simple Sharing Extensions. Basically, if you, I'm thinking like, how much do I want to talk about this right now? Basically, FeedSync is synchronization for RSS or Atom feeds. It's basically an extension to RSS Atom, which is an open format. You can go out to MSDN. The specifications are available under the Creative Commons licenses, but it basically enhances these standard RSS and Atom formats to support synchronization. So it adds metadata needed for synchronization instead of just the plain feed items. We add more information to the metadata just to allow us to be able to sync. The type of metadata that we add reflects the changes to the item instead of just the item. So we might, add part of the metadata to FeedSync, or the FeedSync metadata that gets added is maybe the type of change, whether it's a create, maybe a delete, where the changes happen, what's the ID, and then when the changes happen. So FeedSync is just an extension to RSS Atom that allows synchronization. And then we have file system providers, of course. I've mentioned this briefly, to be able to sync file folders, and then relational providers, which we use as a basis for the sync services for ADO.NET, which I'll talk about momentarily. So at the topmost level, we have the language and API support. And these are more than just providers that we have in the layer below, the built-in sync providers. These take it a step further and have full API and language integrations within the .NET framework. So one such example is the sync services for ADO.NET, as we can see on the top left, which actually rolled out as part of Visual Studio 2008. So we can able to speak the ADO.NET language and still apply a sync scenario straight so we can work with it in our application, in our business logic, right within code. And that sync services for ADO.NET is because ADO.NET works on top of relational databases. Of course, the sync services for ADO.NET works on top of the built-in sync provider, the relational provider. Basically, as we go forward with language and API support, we want to make sure that we we expose and work with other APIs and languages, not just within Microsoft, but managed and native code languages that we have available, but externally throughout partners to make sure that that future technologies, future services, future applications have synchronization built in at the heart of their core API. So we want synchronization to be a part of not just Microsoft products, but other products as they come rolling out. And to do that, we've enabled this language and API extension. So just a scenario for when you want to use one of the different levels of working with the components of the Sync framework. The easiest thing to do, kind of the low-hanging fruit, is on the left-hand side here, is when we say, I have an existing application, I'm building it within Visual Studio 2008, and I wish to sync that application with my server or take it offline and enable this application to work in a disconnected scenario and then synchronize once I get reconnected online. So the lowest hanging fruit would be within Visual Studio, use the language and API support that we saw in the topmost layer. As we move forward to the right and the arrows get longer, we get a little bit more complex and more code that you would have to write as a developer. So in this first scenario where we just want to take an application offline using Visual Studio 2008, it's actually a really simple scenario, and I'll walk through that at the end of this presentation. In the middle, we have the ability to, I wish to sync these endpoints. And these endpoints that we're talking about are endpoints that already have sync providers. So maybe they're both relational databases, so we can use two different relational sync providers, and we just want to synchronize them. Or maybe we have one for FeedSync and then one for a relational provider. But they both have sync providers. Those endpoints have providers which talk. And so it's just a matter of configuration to be able to sync up these different endpoints. Then at the most complex time, we have endpoints that are new or existing that we want to enable for synchronization. So we'll have to write, as developers, we have to write our own sync provider. So to do that, we'll just leverage the core sync runtime to handle things like versions and conflict detection and conflict detection and conflict resolution. So we'll write the sync provider ourselves to expose this application to the sync framework to allow it to be synchronized. Now this is a slide I think that will help us kind of make a lot more sense and draw all this together. It's the anatomy of a sync application. At the topmost level, we have our actual application itself. And that application can do whatever. Maybe it has access to some backend database, relational database, or anything. Maybe it's in the demo that we're going to see, it's our contacts. You know, we have our, we're going to be using contacts as our endpoints, whether it be Windows Vista contacts, Outlook contacts, mobile device contacts, what have you. So the first thing is that we need to have a host application for the sync agent or the sync framework. So whether that host application would be the current application you're working with, or you have a little tiny application you write, as we're going to see in the demo, that handles the synchronization step for you, it needs to have a host. It doesn't have to be a long-running service, as I mentioned before. It just has to have a host. And so the sync agent is who handles the sync provider there. Basically, the application instantiates the sync agent from either managed or native code, depending on how you're going to write it. In order to expose our endpoints, as we can see, you know, pretend like, oops, let me draw that appropriate. Pretend that the endpoints kind of live right around here. Basically, these endpoints could be, you know, Vista contact, and the Vista contact has a data store, which would be like the local file system, and then maybe your mobile device, which has its own internal data store for keeping track of contacts. And then, so we give the sync agent to providers, regardless of the number of stores that we're syncing and the topology. We don't care about the topology at this point of the network. We just have two providers. We have the agent call synchronization, or the application call synchronization on the agent. And then through callbacks and delegates, basically in terms of the point of view of the application, we just sit back and watch. We just sit back and watch our endpoints get synchronized. We don't necessarily care about like what happens, what conflicted, how do we resolve that. We can have the sync agent take care of all that stuff for us. And we do that from the developer's point of view. We do that by either configuring our sync provider, how it's going to handle conflicts, or maybe write new ones specifically for the data store, new sync providers, and then feed it up to the sync agent. So the agent calls synchronization after we call synchronization on the sync agent from the application. The sync agent calls synchronization on the providers and hands them some knowledge. And what we mean by knowledge is that it's basically a multi-mastered token. And this token basically gets handed off, which allows us to do, we can do change enumeration, conflict detection, resolution, and such on this multi-mastered token. Then the store basically enumerates their changes based on this kind of like clock vector here that we see, how it's being changes there. The first point that we do is we take the metadata for this change, for these changes. Let's say the changes happened on this left endpoint via this synchronization, the sync provider here. So the metadata for these changes go over to the second sync provider, and basically based on this token that has the metadata, that it's not the data itself, it's just the metadata describing the changes. The second sync provider's job is to basically go fetch the changes from the first sync provider. So it goes and fetches the actual data, the actual changes from the first provider's endpoint here. And yeah, so and if you're going to do bidirectional sync, it would happen on the exact opposite direction also. Instead of just one way, it will be two-way. So talking about, I kind of mentioned this throughout the entire thing, it's basically to synchronize the two endpoints that we have with the framework, first of all, we have to give them providers. We have to have sync providers for them, either providers that are already out of the box or providers that we have to create our own. And then once we have those providers, we basically have to tell the providers maybe the scope that we want to sync. Maybe we're saying, I want to sync my inbox. I want to sync all my contacts with the last name beginning with R. All my music that is by a certain artist. Basically give the sync provider a logical collection of data to sync. Then we also have to sync the appropriate, or to set the policies of how my sync providers are going to handle conflict resolution. Do we want to prompt the user to choose which which piece of data wins? Do we want to say A always wins or B always wins, etc.? The second point is that we instruct the sync framework sync agent to sync on behalf of the application. And then lastly, we just sit back and watch the results from the application perspective, and the providers are doing all the work for us. So the built-in providers that ship with CTP, Community Tech Preview 1, are also the same within Community Tech Preview 2, which are the file system provider file folder, relation provider, which ADO Sync Services is based on, and of course FeedSync 1.0 that I took a little bit. As new providers come out from Microsoft or via the community or Microsoft partners that maybe they will sell or something, we will make information available on the MSDN site. So it's msdn.microsoft.com/sync, and I'll put a link up at the end of the session. Right now we're in CTP2, Community Tech Preview 2 of the Sync Framework. We haven't added any providers for the Sync Framework, but it definitely improves the performance of the APIs and the core patterns. So there's a lot of improvements there in terms of how it's working. Microsoft Sync Framework itself is scheduled to be released in Q3 of this year, so around the fall time. And also at the same time, we'll be providing some guidance with the Sync Framework around Windows Mobile. So you can expect that in the fall, Q3 2008. And right now, again, we're in CTP2. So you can go down to Microsoft.com, msdn.microsoft.com/sync, SYNC, and you can download CTP2 as well as some other goodies, which I'll talk about momentarily. All right, so before we go into the demo, I want to step through the different type of built-in providers that we have, and then we'll and talk a little bit more about creating providers, and then we'll go into a demo. So one of the first providers is the file folder synchronization provider. It basically works with any type of file system to support either remote or local PCs, like file folder synchronization on remote and local PCs, or even on the same PC from folder to folder or drive to drive, or a USB stick or a removable drive. All we have to do to get it to work is basically instantiate your provider, configure it to sync certain folders, and it handles, the synchronization provider handles the heuristics for, renaming, hierarchy support, conflicts, which way it's going to transfer data between the providers, etc. One such example which uses the file sync provider is SyncToy. And SyncToy is a power toy from Microsoft, so you can go to Microsoft.com and do a search for power toys, and you can download SyncToy. And basically, SyncToy is an application that was, the newer version is built using the Sync framework. And it basically configures the sync agent, creates two instantiations of a file sync provider, just like the diagram that we saw before. I'll just go up and look at it. So SyncToy works at the top here as the application itself. SyncToy configures a synchronization agent. It creates two instances of a file sync provider, and based on the user's preferences, and then the application calls sync on the sync agent, the sync agent calls sync on the sync providers. And then, of course, synchronization happens, and the reports the results back to the user. So it's a pretty simple toy. It's pretty neat. You don't need to see exactly how it's handling the conflicts or the resolution, the renames, and all that good stuff. You just get to see the results. So I'd encourage you to go download SyncToy. Now we'll take a look at the relational provider, basically. The relational provider basically really dramatically simplifies how we take applications and build caching and offline capabilities into our applications within Visual Studio 2008. Has very rich designer support within Visual Studio 2008. And the main key to this provider is basically that it takes the work and the knowledge that we have of ADO.NET and makes synchronization a first-class citizen within the application that you're working on that leverages ASP.NET. ADO.NET and this relational provider. It has delete detection, it handles delete detection, tombstone propagation, and definitely efficient change enumeration for your application. All built in, all out of the box, easily configurable within Visual Studio, and I'll show you that when we go into our demo. I've already talked a little bit about FeedSync. That's an open specification that extends Atom and RSS so that we can add synchronization to RSS or Atom feeds. Basically, it just adds the metadata of the changes to our feeds. Basically allows us to have bi-directional information sharing, so we can not just subscribe to feeds, but also publish them as well. Any provider can use these high-level APIs within the Sync framework to basically consume and produce FeedSync compliant feeds. The Sync framework is going to handle all the markup required for dealing what we call STP, sync tag processing. The framework handles all of that for us. It gives the developers really an easily consumable protocol to use with any type of provider over this RSS Atom channel for FeedSync. So FeedSync is not only its own sync provider, but it basically allows us to take existing sync providers and tie it to this RSS Atom protocol. So I've already mentioned that, we're protocol, we don't really care about protocols. We use arbitrary protocols. It doesn't really matter how our data is being extended. But you can, if you want to, you can tie your sync processing to a protocol like RSS Atom. And basically what that means is, let me go back to that diagram at the top here, is that how we're propagating, how these changes, and first the metadata, and then the changes are getting moved from data store to another. We tie that specifically to a protocol like RSS Atom in the file, in FeedSync's cases, even though we don't necessarily have to tie it to a provider. And if you want to, in terms of FeedSync, you can. Let me find my slide. All right. If we don't have a built-in provider available for you, such as one of the three that we just covered, it's a pretty trivial. Or we put in all the tools to give you all the tools. We put in the framework in place to allow you to expose new endpoints by creating your own provider. So the basic job of a sync provider is to expose the data for that remote endpoint. And the second point is that it should isolate the things that should be internal to that data store. And what that really means is that only that store should know, that data store should know how the data is stored, how locally within that store changes are detected, and maybe the information to that store can't be generalized outside of the store. So the sync provider exposes the data from that store, but it also keeps within that store the things that should be isolated. And basically, the sync framework provides you as a developer with a toolkit that you can use to code against as an abstraction layer, basically a factory pattern, as to how to instantiate a various provider from a given endpoint. and it becomes the sync provider that you create, becomes the interface that you feed into the sync agent to allow some abstraction of that data store. So it becomes that middle layer that we've seen in the slide already. You write that sync provider. The sync provider also that you build uses the common metadata needed for the sync. And the common, I've mentioned this before, the generalization to the sync framework that allows us to work with any type of data over any type of device or service or PC, regardless of protocol, so we can access data anywhere. What allows us to do that, the generalization, does not come from a common protocol. It does not come from using a common data store, but it allows us, but we can do it via a common metadata. This multi-master metadata, common metadata that we require to allow your application to synchronize, all based on the metadata. So let's talk a little bit about it. So what is this metadata and why do we use it? What problems does it solve, basically? The metadata detects what changes, what data needs to be sent in your specific scenario. So regardless of the topology that you're using, it says, you know, I'm in a hub spoke, I'm in full mesh, I'm in you know, a loop or some type of ring. So I'm going to tell you what type of data needs to be sent, you know, like timestamp, the ID of the change, what have you, so we can resolve conflicts. Basically, think of this metadata as this multi-mastery token that another endpoint can look at and see, oh, this is what this, now that I looked at this token, this is what I need to give it. This is the information I need to give it because the token that came from that other sync provider doesn't know about this new piece of data that I have, or the sync provider doesn't know that I have some updated data. So now that I've taken a look at this token, I know exactly what it needs. The second point, basically, is that basically, based on the same granularity used for syncing, the same information we use to figure out how to get new changes or what have you, detecting the same metadata to choose what needs to be sent. We use that same granularity to choose what happens when there's a conflict. The last point is that we guarantee eventual convergence regardless of these things. And basically that means that at some point, regardless of network interruptions, unhandled conflicts, storage and application errors, your data, all things will eventually be synced, you know. Maybe something's offline for a day. When that thing does come back online, we will synchronize it with the rest of with the other endpoints that it is connected to. So, even if your network goes down, there's some kind of exception raised in your network stack, conflicts are logged. Maybe there's another endpoint that because of the topology or something like that gets synced a couple of hops later than the current endpoint that you're working with. Maybe there are write errors for your file access errors or anything like that. Eventually, we will sync everything all at once, so it's guaranteed. Also for talking about the common metadata, basically, when we agree on the common metadata versus agreeing on a common store or a common protocol, the reason we chose agreeing on a common metadata allows for full interoperability between sync providers. Basically, because it's really low-hanging fruit. Just to agree on common metadata to exchange. Any provider, any endpoint can agree on common metadata. They might not be able to agree on what kind of data store they're using or what kind of protocol they're using, but they can agree on common metadata. Also, chances are we don't have to agree on storage technology, because chances are you have somewhere where you can store your metadata, It doesn't even need to be within the same data store. It doesn't have to be with the item. The only requirement is that you can produce this metadata when you're requested and save it. And then we even give you the ability to use a metadata store within our Sync framework without agreeing on storage representation. So we don't exactly how you're going to store it or what it looks like. We don't necessarily agree. And of course, we don't agree. We don't need to agree on what type of protocol you're sending information over. And the second point that we have on the screen is that the Sync runtime gives developers a really high-level abstraction over the metadata schema, which basically allows us as developers to concentrate on how we're implementing and writing code behind our provider, or how we're configuring maybe an existing provider. So we don't really need to get really granular on exactly the schema. We have this SDK to hide that complexity. With Sync Provider Services, this is one of the, let me scroll back up here. Sync Provider Services, which is this third point down here where we have the metadata store and the anchor and simple providers. Just scroll back down there. Basically, these services that we provide you as developers to be able to write your own sync providers, which easily expose your endpoint to the sync ecosystem. Basically, we recognize that not all your data stores are created equally. Maybe you have a data store like a USB drive, and that USB drive is a data store that can't detect local changes. It doesn't keep track of any changes that are made locally. Or maybe it doesn't provide a rich way to enumerate those changes. So we've given you ability to have anchor and simple stores, so you can leverage, maybe you do have a data store like a relational database that can keep track of changes that are made locally. So you can use the anchor provider services for that. But if you don't have a data store that can keep track of local changes like a USB key, you can use a simple data store. We also have an optional SQL CE implementation to use the metadata store service that one can use to populate the metadata, the info into. Let me go back up to that slide. So first off, you can use these anchor providers to, as I mentioned, maybe have your data store has some intelligence as to how it can deal with changes. Or if it doesn't, you can use these simple providers that doesn't have any work in the background. But in the metadata store, maybe if you can't store metadata or something like that, we have an optional SQL Compact Edition implementation of a store service to store that metadata. And then lastly, we also, within the Sync framework in terms of services, we have the ability to filter sync subsets. So maybe in this example, you want to sync the last 2 days of email, or all music that you've marked as 4 stars, or again, all music artists that begin with the last name are. And my last slide before we go into the demo is that we have the Microsoft Sync framework enables cross-platform support. So we can use native or managed code for support and develop Sync applications, or do all this for Windows 2003, XP, Vista, and in the future Windows Mobile. But we wanted to make sure that we had this Sync, we enabled this technology available for licensing across non-Microsoft platforms. So if you want to take a look at that, head out to msdn.microsoft.com/sync for contact information. Now what I'm going to do is, with our last 10 minutes, play a video for you which handles a synchronization scenario. So let me get that set up for you. Hopefully you can see that.
Hello everyone, I'm Lynn Kavanaugh, Program Manager with the Data Replication and Synchronization Group. Today I'd like to talk to you a little bit about the Microsoft Sync framework. I'll go through a bit of a demonstration to show the concept of the technology and some of the things that you can potentially accomplish with the Sync framework. As you can see in this diagram right here, we have a number of different potential data stores where we could store information. Now, ultimately what we want to do is show how we can integrate each of these disparate data stores to allow synchronization to take place between each of them. Now, what we're going to do is start out with SQL Server, and we're going to show how we can take information and synchronize it to some data stores such as Outlook Contacts, Pocket Outlook on Windows Mobile, Vista Contacts, an actual Outlook store, as well as Hotmail up to the server side. And we're going to show how we can use providers and ultimately the same framework to accomplish that. So let me switch over to my demonstration. So here we have a little application that we've created. This is an application for a company called Fabricam, a furniture store. And what we're going to be using this for is show how we can enter in customer information. Now, this information gets stored in a local SQL Server database. This SQL Server database would be housed at each of the Fabricam furniture stores, and potentially using one of the existing Microsoft synchronization technologies to move that information up to the corporate servers. So that might be merge replication, might be sync services for ADO.NET. It doesn't really matter. That's not really the focus of our talk today. What we're going to talk about is how we can integrate this data store with different data stores outside of the database, whether that's Outlook or Windows Mobile or whatever you might want to synchronize to. So let me get started. I'll click on Customers here, and this will open up an application and allow me to enter in a new customer. So enter in some information, test company, put contact name, John Smith, telephone number, email address, ship to address, Redmond, Washington, and another number, 1, 2, 3, 4. So let's just remember, actually this one's just a little bit different than the previous number. So remember phone number 1, 2, 3, 4. Click on OK, save that. Now of course, what just happened there? Well, we've saved that change to the local SQL Server database. So down here in the bottom right-hand corner, I have my Microsoft Sync Framework application. Now what I can do is I can choose to initiate synchronization, or what I'm going to do is enable the autosync. And what that will do is it will monitor any changes that have occurred from that point forward and synchronize those appropriately. So just for now, I'm going to initiate a synchronization, take the changes, move it over, and let me open up the Outlook data store. And we can see how we've completed a synchronization over to Outlook here. And I can open that up, take a look at that contact, make sure all that information has come down, which it has, and we can close that down. Now, what I can do from this point is I can allow my users to synchronize even further. Imagine at this retail store, the salespeople are loving the ability to synchronize to their contact folder so that they can send out mailers and coupons to important customers. Imagine now that if they wanted to take that information and bring it down to their mobile device so that when they're on the road visiting customers, distributors, they have that contact information right available to them. Well, what we can do is we can write an application to synchronize that down. Now imagine I took that framework and I actually embedded that into my actual Outlook folder. Well, as you can see here, we have synchronized contacts embedded right in here. So let me click on that, and you can see how it's actually integrated into our task application. Synchronization is taking place and synchronizing it down to my Windows mobile device, which I've enabled right here. Once again, that information is now moved down to my Windows mobile device. Let me take a look at that contact in a little more detail. Here we go. Here's that contact, John Smith, all the same information. In fact, let me make a little change to it. That's not actually the proper telephone number. He has a new phone, and it's actually 9999. I'll click on OK, save that change, and now that change has been stored and is now ready to be synchronized to any of the other data stores. So once again, let me click on Synchronize. Before I do that, let me just bring up my contact folder here. Look at it as it exists right now. Here we go. Here's my Windows mobile contact. And as you can see, I don't actually know about this change for my Windows mobile device. So let me just make sure I can synchronize that and move it up to that side. And that's completed successfully. Sometimes it takes a little bit longer because we're actually sending it to some of the server stores, which we'll see in a minute. We're going to click on Open this time, click on Home, and here we see the new telephone number, which has been synchronized as well. Now, once again, I can move it even further. Imagine I wanted to be able to take that change and actually move it up to a server side. Maybe I wanted to take that into Hotmail. Let me make another change to that. This time I'm actually going to, close down on my device. I don't need that anymore. And let me move it up to 000. Click on OK. Synchronization, because I have auto sync. It's detected the change on my desktop. Let me open up Internet Explorer. Log into my Hotmail account.
Now I'm just going to stop that video there just because it's just going to show us do the exact same thing with Hotmail, but because just the interest of time, I want to give you some resources to take a look at, and I'll finish up with a couple of questions. So for more information on the Sync framework, we just saw a quick scenario, but go to msdn.microsoft.com/sync, and there you can watch a version of this presentation again. You can also see some more presentations about the Sync framework and FeedSync and such. But one thing I want to point out is that you can go to my blog again and ask me questions via my blog. But lastly, the demo that you just saw, you can download the code for that demo as well as code for a few other things. One is a very simple sync application. The other one is a FeedSync, using FeedSync from this code gallery, MSDN's code gallery. So go to code.msdn.microsoft.com/sync, and you can download those demos. And I will, of course, put all this information up on my blog. The last thing I wanted to show you really quickly is the ability to have use the built-in functionality of sync services for ADO.NET that's built into Visual Studio 2008. So I have an application here. It's very simple. It's basically a doctor's application, so we can monitor patients and monitor the prescriptions of my different patients as a doctor here. And I want to be able to synchronize that application. So I'm just going to walk you through really quickly the steps that you need to take to be able to take a certain application and allow for offline access by creating a local data cache. To do so, we just go to our solution and we'll click on Add a New Item. And to add a new item, we'll go down to our Data tab for our templates. And we see the ability to add a local database cache. And this local database cache has the file extension of .sync, and we can just call it, we'll just do demo1.sync. Click on Add here, and it's going to pop up a wizard for us to go through to configure our application for data synchronization. First thing it's going to ask is for our server connection, and we can say, I have a server database called CHC database. And then it's going to do the client connection, use the local SQL CE database for our local version. And it's going to create, in this case, with parentheses new, it's going to create a new database called, a new SDF file called CHC database. And then I can take my application and add specific tables to cache from my server-side store. So in this case, I'm just going to, I'll cache my prescriptions table. And then we have the ability in the sync services for ADO.NET to, to figure out the granularity of how we're going to handle conflicts, handle comparisons, when's the last edit, creation date. If we delete items, what are we going to do with them? It'll also generate server-side scripting. This wizard will generate some scripts as to which and how to undo changes that are going to be made to our database. So I'll click OK there. We also have this show code example. So now I can show code example and copy and paste this code to my clipboard. And this is the code that is going to synchronize that local database SDF file with the remote database. So should I want to call sync, I just have to copy and paste this code. And click OK. So once I click OK on that wizard, what it's going to do is to create this new CHC database.sdf file, and it will synchronize the tables that we had in our remote database with this new SDF file. the other thing it's going to do is create a new data source for me to be able to use within my application. Sorry, this new data set for me to use within my application. So I'll click Finish and just show you what was generated for me. So if I look at my Solution Explorer, the first thing that we're going to see is we have a couple new references, one to system.data.sql.ce, Microsoft.synchronization.data, synchronization.data server, and SQL Server CE to allow those API changes and language integration for ADO sync services. We also have the SDF file, the data set, and our sync item, which the wizard generated. And if I double click on that sync item, we would see, we'd go back to that wizard. Also, lastly, I just want to take a look at showing you the Server Explorer, where we have our new SDF database, and then our existing CHO database. And if we took a look at the tables, we'd see the tables that we already had, and then it added this new prescriptions tombstone table to move deleted items to. If we took a look at the data columns, we'll see we have a few more columns added, such as last edit date, creation date, and a couple of triggers to make sure that our data gets synced appropriately. And if we took a look at our local database cache, we have the prescriptions table, which is the one we chose, and then some columns, last edit date and creation date, to allow synchronization. So it really is just a matter of walking through a wizard, pointing and clicking. We can use the designer here. The next step that I would do that I don't really have time for is to add another button to my WPF, in my WPF designer to allow synchronization, and then I would take that button, go down into the code for it, and basically copy and paste that code that the wizard generated for us to allow synchronization. So that's that for me. I know I've gone over a bit of time. Again, go out to my blog, msdn.com/Lindsay, and I'll post these links up there, as well as answer any questions that you may have that have been asked during this webcast, okay? So thank you, everybody, and I'll hand it back to you, Tracy, for any last-minute things. Also, please feel free, please fill out the survey at the end that Tracy is about to direct you to.
Excellent. Thanks so much, Lindsay. All right. Now, if you have any remaining questions for our presenter, go ahead and submit those into the Q&A pane, and we'll get to those at the end of the session via text. I do want to remind everyone that you may print a PDF of the slides today by clicking Control-P. You can either print the slides or save them locally for your convenience. Also, watch your inbox tomorrow for information about viewing this webcast on demand. This email will also include a link to a downloadable PowerPoint of today's webcast. And also, we'll be posting that survey here in just a minute. Like Lindsay said, we do appreciate any feedback that you leave for us. Also, for upcoming and previously recorded webcasts, you can visit Microsoft.com/webcast. You can also go here to access the recording of this session, which will be available in about 24 hours. And if you have any webcast content ideas, something out there you'd like to see and haven't yet, we'd love to hear from you. Just take note of this link here. And now here's the survey from our session today. Please follow the links provided to complete today's webcast evaluation. Like both Lindsay and I said, your feedback really allows us to kind of create better webcasts for you. And with that, I do want to extend a very special thank you to Lindsay for your presentation today. Also a big thank you to everybody for joining us for today's MSDN webcast. Well, ladies and gentlemen, this will conclude today's session. Thanks for joining us. You may now disconnect from the audio portion of today's presentation.